Okay, so we're going to take a look at an example where we're going to graph functions without equations. We're going to apply horizontal and vertical expansions and compressions to them. So the first one will be a horizontal stretch, the second one will be a vertical stretch, and the third one is going to be both. Okay, so the function that we are going to transform is the first graph, y equals f of x. I have already written in the coordinates for each point. On the first one, we're graphing y equals f of 2x, so that is in the form of y equals f of bx, which means we are looking at a horizontal stretch. That means no change in y. Okay, so by looking at our function f of 2x, we have a b value, which is 2. And remember that horizontal stretches are 1 over the absolute value of b, so I'm going to plug in the 2 for that. And so the 1 over the absolute value of 2 is a half, which means that we have a horizontal compression of a half. Okay, so notice our b value is 2. Get the reciprocal of that. That tells us we have a horizontal compression of a half. So if negative 1, 3 is on the graph of y equals f of x, which it is this point right here, okay, where will it be after the above transformation? All right, so let's take our point, negative 1 and 3. We are going to apply a horizontal compression of 1/2 to that. That means we will change only the x coordinate, and we want to change it by a half. So negative 1 divided by 2 becomes negative 0.5 and 3, and negative 0.5 and 3 is right here. So negative 0.5 and 3. Okay, so that's the corresponding point on our transform graph. Now notice it is a half a unit away from the y-axis, right? So horizontal stretches tells us like how far are we away from, or sorry, it's the change in the distance away from the y-axis. Okay, so on the first graph, our point is 1 unit away from the y-axis. On this one here, on the second graph, it is a half a unit. So that means that every point on our original graph has to be half the distance that it was from the y-axis, and our y coordinates stay the same. It's our x that changes. Okay, so if you notice, it used to be negative 1 and 3, now it's negative 0.5 and 3. Okay, so if we take the point negative 3 and negative 3, which is 3 units away from the y-axis, it now becomes 1.5 units away from the y-axis, and so the new point would be negative 1.5 and negative 3. Okay, all right, that's the top part. And if you take a look at the points that are on the x-axis, they will also become half that distance. So the first point is 1 away, it will now be a half away right here, and the second point is 3 units away, so now it's going to be 1.5 units away, and we can join our points now. Now if we take a look at the bottom points, okay, so this one and this one. On the one on the left, we count 1, 2, 3, 4, 5 units away from the y-axis. Half of 5 is 2.5. We're still going to keep our y the same, so we're still down at negative 3, but we're going to be at 5 divided by 2 units away from the y-axis, so 2.5. Okay, and if you take a look at the point on the right, it is 1 unit away from the y-axis, so now it becomes half a unit away. Keep your y coordinate the same, and this becomes your new graph. Okay, so notice it's skinnier, right? It's still as tall. They're both the same height, but the second one is now narrower than the first one. Okay, on the third graph, okay, or the third column that we have here, we're going to graph y equals 2f of x. So this is y equals a f of x. This means that we have a vertical stretch, and if we have a vertical stretch, there is no change in x. Okay, so our x-coordinates stay the same. It's our y-coordinates that are going to change. All right, so remember, if we have a vertical stretch, we're looking at the absolute value of A to get our compression or expansion, okay? And our value is 2, our A is 2. If we take a look at this, A equals 2. So the absolute value of 2 is 2. And we have a vertical expansion of 2. Okay, so we don't think reciprocal on this. All right, we're now looking at the point -3 and 0. The point -3 and 0 is right here. Okay, and we will apply our vertical expansion of 2 to that. Remember, that means that it's only the y-coordinate that changes. And in this particular case, our y-coordinate isn't going to change, right? Because 0 times 2 is 0. So that means that that point is an invariant point, right? And invariant points for vertical stretches are on the x-axis. Okay, so let's pick another point then. Why don't we pick the same one that we did on the first column and see what happens to that? We have -1 and 3. We're going to apply a vertical expansion of 2 to our y-coordinate. So our first x-coordinate stays the same, but 3 times 2 is 6, so it becomes 1 and 6. Sorry, -1 and 6. Okay, so our point -3 and 0 stays the same, so we can plot that right here, -3 and 0. But our point -1 and 3 becomes -1 and 6, which is up here. Okay, and I'll highlight that in yellow because that's what it was on the first graph. Okay. Okay, so notice, let's take a look at the -1 and 6. It's still 1 unit away from the y-axis, but the distance from the x-axis has doubled, right? It used to be 3 units up, now it is 6 units up. All right, so we have vertically stretched it by a factor of 2. All right, notice -3 and 0 stays the same, so you can speculate and extrapolate that the -1 and 0 is going to remain the same too, because your y-coordinate is 0, and 0 times 2 is 0. All right, so if you take a look at the first graph, the point -3 and -3, it is 3 units above the x-axis, and now, hang on, that should be +3, correct? Yeah, sorry, +3. Okay, it is 3 units above the y-axis, so now it's going to become 6 units above, so we have a point right here. All right, and then we take a look at the blue points on the first graph. They are 3 units below the x-axis, so we're going to double that distance now to 6. We keep our x-coordinate the same, so it's still at -5, but we're going to go down to a y-coordinate of -6. And the second point on the right of the y-axis is 3 units below the x-axis. It now becomes 6. We still keep the x-coordinate at 1, but our y-coordinate goes down to -6. And we join our points and we get this graph. So notice there is no horizontal compression or expansion, right? It's just as wide as it was before. But notice that the length has changed. The length has doubled. Okay, it's twice as high. Okay, in our next example, we're going to apply 2 different stretches, a vertical stretch and a horizontal stretch. So what we have then is a graph in the form of A, F of B, X. Okay, so our A value is 1/2. That means we have a vertical compression of a half. Our B value is 1/2. Okay, remember we have to think reciprocal. So that means we have a horizontal expansion by a factor of 2. Okay, so our vertical expansion of 1/2 means that our graph is going to become shorter. Our horizontal expansion by a factor of 2 means our graph is going to become wider. Okay. All right, the point that we're going to transform is -5 and -3. And we are going to apply both the horizontal expansion of 2, which gets applied only to the x-coordinate, and a vertical compression of 1/2, which gets applied only to the y-coordinate. Okay? All right, so -5 times 2 is -10, and -3 times 1/2 is -1.5, right? All right, so -5 and -3 on our first graph is the far left blue point, okay? Now it becomes -10 and -1.5, so -10 and -1.5 is right here. Okay, and that will be, oops, blue. All right, to show what happens to that point, okay? Now, I don't go through and transform every point algebraically like I did on the bottom of all of these examples, so I just kind of visually do this. Generally speaking, when we're working with transformations, we work from left to right. Okay, which would mean we do our vertical stretch first and then our horizontal stretch. But when you're working with stretches, it doesn't matter which one you do first, okay? But I am going to start with the vertical compression of 1/2, and then I will do the horizontal expansion by a factor of 2. Okay, so I'll do the vertical compression in blue. And actually what I'll do first is put on the original graph. Okay, so we have a point at -1 and 3, and -3 and 3. Okay. And then we have a point at -5 and -3. So 1, 2, 3. And then 1 at 1 and 3. Okay, so this is our original graph. It looks different just because our grid is different. Okay, so the first thing I want to do with that, and I will do it in blue, is I'm going to give it a horizontal compression of 1/2. Okay, that means half the distance for everything. So half the distance away from the y-axis. Everything else stays the same. Okay, so the width is going to stay the same because we're not doing a horizontal stretch. We're just going to change the distance from the x-axis. So half that distance. So let's take a look at the far left point. It is 3 units below, so it becomes 1.5 units below. The one on the x-axis stays the same. The next point is 3 units above. It goes 1.5 units above. The next one is 3 above, so 1.5 units above. The next point stays on the x-axis, and our very last point on the far right becomes half that distance to the x-axis, and so we get this graph. Okay, and I'm going to do the horizontal expansion by a factor of 2 in green. So now we're going to take all of our points and we are going to increase the distance from the y-axis by a factor of 2. So once again, we're on the far left. We're at -5 away from the y-axis, so -10 away from the x-axis, or sorry, the y-axis is at -10 and -1.5. Okay, our next point is 1, 2, 3 units away from the y-axis, so now we're going to increase that distance to 6, so it will be right here. The point above that is also 3 units away from the y-axis. We will now increase it to 6. And then the next point is 1 unit away. We will increase it to 2. And same with our next point. And then the one which is on the right-hand side of the y-axis is 1 unit away from the y-axis. We are now going to make it 2 right here, by a factor of 2, right? Okay, so this is what we get. Okay, so the green graph is the one that is our final our final graph for y equals 1/2 f of 1/2 x, okay? So if you want to do the horizontal expansion by a factor of 2 first, you can, and then do your vertical compression by a half. Second, that's not a problem. You will arrive at the same graph, okay? Now, if you don't really like doing it from the graph, you can take all the points and transform them the same way that we did below here, okay? You could take all of the points from the first graph on the far left and transform all the points, and you will arrive at the same answer, okay? So this concludes example number 3.